Welcome to Designing and Planning EnGenius Wi-Fi Products. This webinar is for those new to EnGenius Wi-Fi products and would like to learn how to choose the right model for deployment. I'm Jerry Tenorio, Field Application Engineer, and your presenter. Let's start with some basic terminology. Access point, or AP. This allows a wireless client device, such as a laptop, to connect to a wireless network using Wi-Fi. Think of an access point as a central point of communication. Wireless clients communicate on the network through an AP as long as they're within range of that AP or access point. Client bridge. This is a device that connects an Ethernet network or Ethernet device directly to a wireless access point. Client bridges are standalone devices that allow pretty much any Ethernet-ready Ethernet device to have Wi-Fi connectivity. This could be a printer or something such as an Xbox or even a digital billboard. Two types of Wi-Fi networks: ad hoc, which is used in many point-to-point deployments, and infrastructure. In ad hoc mode, each client is basically communicating via peer-to-peer. There is no access point in this type of setup. Infrastructure, or point-to-multipoint mode. The infrastructure mode requires the use of an access point. In this mode, all wireless communication between clients are through the AP or access point, no matter the location of the AP. Infrastructure is the more common type of wireless network that people are familiar with. Wi-Fi standards. The first Wi-Fi standard that was popular in the United States was 802.11b. It operates on the 2.4 gigahertz frequency, has a data transmit rate of up to 11 megabits per second, and uses DSSS modulation. Another Wi-Fi standard, which came out right about the same time but didn't become as popular in the United States, is 802.11a. It uses a higher frequency, has a throughput of up to 54 megabits per second, and uses OFDM modulation. 802.11g uses the 2.4 gigahertz frequency and applies that OFDM modulation of 802.11a on this frequency band in order to get the throughput of 802.11a, but on 2.4 gigahertz. 802.11n, which was recently ratified, can be used on both 2.4 gigahertz or 5 gigahertz. It's basically an add-on to the other three standards. Both up to 300 megabits per second throughput using MIMO, which stands for multiple in and multiple out antennas, as well as spatial multiplexing and wider channel width of up to 40 megahertz channels. The previous A, B, and G standards only utilized 22 megahertz channels. Now here's a very simple wireless network, as the type of network that you would see in a home. In this example, we have an ESR 1221 EXT acting as a wireless router. As you can see, where a wireless laptop or a computer with a wireless network adapter can connect to it. You can think of an access point also as a hotspot. This is usually the common term used at a coffee shop or small office, but it's still the same basic concept, whether it's applied indoors or outdoors. For these simple applications, these models are what we recommend for smaller home or apartments. The ESR 1221 EXT, which boasts 200 milliwatt output power. Why we stress the output power is because most other leading brands only have about 50 milliwatt transmit power compared to the 200 milliwatt output power of this tiny yet powerful router. Another way to have long range is using 802.11n technology. We have the ESR 9753, which borrows some of the 802.11n technology. Then we have an ESR 9752, which is an N-spec router. For medium to large homes, we recommend the ESR 9850 300 megabit gigabit N router and the ESR 7750 300 megabit dual band router. We also have the ERB 9250, which is basically a wireless repeater. To go with your wireless router, you do need to have matching technology on the other end to get full benefit. For small home and apartments, usually an EUB 3701 EXT should suffice, or the EUB 9703. If you require longer range, we suggest high power devices such as the EUB 362 EXT, which boasts 200 milliwatt output power, and soon to come the EUB 9603H, which boasts up to 600 milliwatt output power. Or you can choose 802.11n devices, which give you better range than normal G power devices and high throughput speeds of up to 300 megabits per second. Now we'd like to transition to our business class models. They have higher RF transmit power and sensitivity than the models we just mentioned. Also in our business class models are the added power over Ethernet capability. This allows you to deliver both data and power over a single Cat5 Ethernet cable. For larger coverage areas, several APs can be deployed to appear as a single wireless network. High transmit power and receive sensitivity mean using less APs. You must remember that dB loss is a function of material, so the type of material that the building is made of will affect the number of APs required to do the job. Brick or concrete walls, as rule of thumb, usually can cover 15 rooms per AP in a hotel, compared to if the hotel were constructed of drywall, you might be able to cover 25 rooms per AP. So you can see here, usually that's because through a brick wall you have about 8 dB loss per wall, versus with drywall you only have 4 dB loss. Our recommendation for these types of deployments would be either the high-powered 802.11g APs, the EAP3660, or the ECB3500. If you choose to use 802.11n technology, the EAP 9550 or ECB 9500 would be the recommendation. Here are some of the specs for the ECB 3500. This is an 802.11g access point / client bridge. It boasts up to 600 milliwatt RF output power. It has dual antenna diversity. It is an 802.3 AF power over Ethernet capable device. It supports multiple SSIDs and VLAN tagging. Why this is important is because now you can have this device broadcast several SSIDs with different levels of access. So for example, SSID 1 would be for guest users to allow them to have internet access, while SSID 2 could be for, say, your security team which will access a whole set of different other resources that your guests cannot see. Another feature is WMMQoS, which is important for voice over IP and multimedia applications. And as mentioned earlier, this device is not just an access point, it is a client bridge and has 5 other modes. The EAP 3660 is an 802.11g access point. It's basically similar to the ECB 3500, but is tailored more for a hotel type deployment. As you can see, it has a smoke detector type enclosure, has a 4 dBi internal antenna. The specs are similar in its capabilities, except it does not have all the multiple modes as the ECB 3500. The ECB 9500 is similar to the ECB 3500, except it is an 802.11n access point / client bridge device. One major difference besides the 802.11n radio capability is the gigabit Ethernet port. The EAP 9550 basically is the 802.11n counterpart of the EAP 3660. It does have a 4 dBi MIMO smart antenna to take advantage of the 802.11n capability. Point-to-point long-range links. Usually we recommend either the EOC 2610 or 5610, depending on which frequency band you plan to use. The key to this being successful is usually having clear line of sight and proper antenna alignment. When we say clear line of sight, a lot of people think it's a laser line of sight. What this means is really that the beam of the antenna, less than 30% of it is obstructed. Clear line of sight is key on both ends for long range, and this is a lot of times this is referred to as an ad hoc network. Like I said, we usually recommend the EOC 2610, which is an 802.11g device operating on the 2.4 gigahertz band. Or if the 2.4 gigahertz band is crowded in that area, we would recommend the EOC 5610, which is an 802.11a device, which operates on the 5 gigahertz band. Here are some of the specs for the EOC 2610. It has an IP65 rated outdoor enclosure. 802, as mentioned, it is an 802.11g device. It has up to 600 milliwatts RF output power. It comes with its own 24 volt power over Ethernet injector. It has an integrated 10 dBi internal antenna with an option to use an external antenna via an RP SMA connector. It also comes with a metal clamp for mounting onto a mast. The sister device is the EOC 5610. It can operate on either 802.11a or G, meaning it can also operate on the 5 gigahertz band instead of the 2.4. The antenna spec is slightly different. When using the 2.4 gigahertz band, the dual band antenna has a 5 dBi gain. When using the 5 gigahertz band, the antenna gives 13 dBi gain. Antenna options are very important. How the device is used determines what kind of antenna is needed. Omnidirectional is best used where AP and clients are at the same elevation. You have a flat circular radiation pattern. Directional antenna, usually recommended when you want to have a long-range link. With directional antenna, you have a focused beam, and you can go miles if provided that you have clear line of sight, minimal interference, and proper antenna elevation and alignment. Point to multipoint outdoor omnidirectional antenna. In this diagram, you see that omnidirectional antenna is on the AP, while the client bridges are using directional antennas pointed back at the AP. This is the same basic concept as the home slide, the very first slide we looked at, except on a larger scale with higher power devices and directional antennas. The EOA 3630 is basically the outdoor version of the ECB 3500 and is the choice access point for this type of application. It has, just like the EOC 2610 and EOC 5610, has an IP65 rated enclosure. It has 600 milliwatt output transmit power. It has a Type N RF connector, comes with a 24 volt PO power over Ethernet injector, and has a wall or mast mount bracket. For outdoor hospitality, such as RV parks, marinas, campuses, amusement parks, basically places where running data cables is not an option, we recommend having a dual radio repeater. That way you separate backhaul traffic from the wireless traffic used by your wireless clients. The recommendation would be the EOR Sony 750. As you can see in this picture, this is an older diagram of how we used to recommend two models in that middle dome. You would used to need two separate devices, one had to act as a client bridge and one connected via Ethernet connected to an AP to broadcast out the signal. Now with the EOR Sony 750, because it's a dual radio repeater, one radio will be acting as the backhaul to communicate with other EOR Sony 750s only, while the other radio allows communication to your wireless clients, as seen here, like such as a Wi-Fi phone and laptops and other types of Wi-Fi devices. The EOR Sony 750 has an IP65 outdoor radio enclosure. Now radio 1, which is recommended as the backhaul radio, can be either 2.4 gigahertz or 5 gigahertz and has a transmit power of up to 600 milliwatt. This device has a Type N connector for radio 1. Radio 2 is an 802.11n radio that works on 2.4 gigahertz frequency and uses an internal 6 dBi internal antenna for radio number 2. Just like the other outdoor access points, this device comes with a 24 volt power over Ethernet module and can be wall or mast mounted. Now applying concepts for a WISP model. The EOC 2610 configured in client bridge mode is a popular choice for being deployed as a CPE device by WISPs. As you can see in this diagram, it's being used in place of a cable modem. You can think of it as a wireless modem that's connecting to the access point that's out on a tower in the neighborhood. One vertical market that's becoming very popular is the IP security camera. an EOC 2610 or other EnGenius client bridge model can attach to these types of cameras because they are Ethernet ready. And even if the camera is wireless, a lot of times the range of the radio integrated into the camera is not very powerful. So a lot of security specialists who like to see better range from that usually choose a device such as the EOC 2610 to give it longer range wireless capability. As you can see here in this diagram, the security cameras will beam back to a central access point in the main building, which is wired down into a DVR server. Now these concepts we just talked about can pretty much apply to any Ethernet device. EOC 2610 configured in client bridge mode in this scenario is used to send data over to billboards, digital billboards, or messaging devices. Here are some other various deployments, real-life deployments used by our customers. To the left is an ECB 3500. While we introduced it as an access point earlier, since it is capable of multiple modes, it is being used as a client bridge to provide wireless connectivity to a network printer. The middle picture shows the EOC 1650, which we didn't talk about. It's basically a miniaturized version of the EOC 2610. It boasts 200 milliwatt output power. What's good about this device is it's more of a semi-permanent device, which can be easily mounted onto a radio. Onto a window. Sorry. And to the right is an older EOC client bridge model, which is being used on a boat in a marina as a client device. Because a lot of times, once you go below deck on a boat, a wireless laptop does not have the power to connect back to an access point. So putting in a client bridge device on the boat and then connecting to the Ethernet port of your laptop will allow you to connect to the marina's Wi-Fi system. That concludes our presentation. If you have any further questions, feel free to contact us. You can send an email to info@engeniustech.com or call us at 888-735-7888, or feel free to browse our website, www.engeniustech.com. Thank you.